Problem number 1. Plot a point for each of the first 3 ordered pairs in each table. Connect the points for each relationship by drawing a line through the points to the y-axis. So for stall A, we're going to plot 2, 4, 4, 8, and 6, 12. So we go 2, 4, 4, 8, and 6, 12. If you look, you'll notice that that is a proportional relationship. We are then going to plot the points 2, 8, 4, 10, 6, 12. So 2, 8, 4, 10, and 6, 12. That one starts at the 6 and crosses. Problem number 2. Look at your graph in problem 1. Does the line for either the proportional relationship or the relationship that is not proportional go through the origin? If so, which relationship? So, stall A goes through the origin. So stall A is proportional. Problem number 3. Suppose the cost of 10 pounds of grapes at stall A is $15. Would the relationship still be proportional? Explain. So this would be 9, and so we would say that this one right here would be 10, and so the price would be 15, so that would be about right here. And so, no, it would no longer be proportional. Because the graph would then change. It would go up like this, and then it would curve to the side. To be proportional, it has to be linear and not have any curves or bends. Problem number 4. The number of cups of water used in 2 different soup recipes depends on the number of batches of the recipe you make. The tables show the number of cups of water used in the 2 soup recipes. Do the ratios of cups of water to batches of soup in each table represent a proportional relationship? Explain. So if we were to fill in the chart, you would see that this one goes 2, 4, 6, 8, so we're counting by 2s, whereas when we go 6, 12, 18, 24, we're counting by 6s. So if we go the opposite direction and go down, this would put us at 0, and if we went down 6, that would put us at 0. Recipe A is proportional because it goes through 0, 0. For recipe B, you'll see that when we go 1, 3, 5, 7, we're counting by 2s. 4, 12, 20, and 28, we are counting by 8s. So if we were to go down, if we can go ahead and write that as 2 over we can write that as 8 over 2, our fraction rise over run, which is 4. So if we went down 1, we would be going down 4, meaning it would be at 0, 0. The recipe B is also proportional. Number 5. The graph shows the data from the tables in problem 4. Which line represents recipe B? Explain how you know. Well, recipe B starts at 0, 0, just as this graph does. It then has a point at 1 and 4. It has a point at 3 and 5. Or excuse me, 3 and 12. 3 and 12. 5 and 20. 7 and 28. So the black line is recipe B. Because the points match. Number 6. Use the graph that you identified in problem 5 for recipe B to find out how much water is needed for 4 batches of soup. Is the ratio of water to batches equivalent to the ratios you found in recipe B in the problem? So, if we were to do that for four batches of soup, the point would put us here at 16. So it should take us 16 cups of water to make 4 batches. If you follow it, our ratio was 8/2, which simplified down to 4 cups. 4 cups per batch. If we have 4 batches, 4 times 4 gives us 16. And so our answer is correct. Number 7. Thomas collects sports cards. The number of baseball cards he buys each week is proportional to the number of football cards he buys. Fill in the missing numbers in the table. For problem 7, it would be easier if you put them in order. So if you look, they start with 9 baseball cards and he buys 6 football cards. Then he buys 15 baseball cards. So 15 is not next to 9, so I'm going to put that down here. We then have the 6 baseball cards also, and so that's going to be below the 9. From here you can see that from 6 to 9 we're going up 3. So we can assume the next one's going to be going up 3, which puts us at 12, which follows the pattern. 12 plus 3 is 15. So our missing spot here is 12. You can also see that when it's 12, our football cards are 8. So the football cards are going up 2. So you can continue that pattern and get 10, and then go back down and get 4. For letter B, it says, suppose Thomas buys a total of 30 baseball and football cards in week 5. How many of each would he have to buy to keep the same proportional relationship? We can simply continue the pattern as we were doing. If I go up 3, again, that puts me at 18. I go up 2, that puts me at 12. 18 plus 12 gives me 30. He would buy 18 baseball cards and 12 football cards.